Welcome back. What do you call a nose with no body? Nobody knows. Okay, we've got another video. We are going on to equations of lines. So this is going to be everything to do with lines. I hope it won't be too long, but let's not forget stuff that we remember. Y equals mx plus c. That's what we call our gradient intercept form. Hopefully you remembered that the m stands for the gradient and then the c stands for the intercept. We could also write it as, some sort of x plus some sort of y plus something else equals to 0. Whenever you've got that, that's what we call our general form. And let's not forget, if you have an x equals to something or a y equals to something, those are just our vertical and horizontal lines, respectively. That's not exactly what we're going to talk about, but it's just helpful. What I mean by that is what we're looking today is we're trying to find the equation of a line. Okay, now I want you to grain this into your head. Whenever you hear the word find the equation of a line, 9 out of 10 times you're going to be using this formula here, the point gradient formula. Now, what do you need for a point gradient formula? Well, it's kind of in the name. You'll need a point and you'll need a gradient. Okay, now just take a note here. When I've talked about a point, I'm talking about, something, some x and some y, a singular point. And then your gradient is kind of m. So we can see that this comes up in our formula. You can see that the point here, the x1 and the y1 is that's the y1, that's the x1. We don't really touch that y and that x, and I'll explain why in a little bit. This formula is not given, so you're going to have to memorize this one as well. You use it really often, especially when we get to calculus, but we'll get there in a little bit. Okay, now, when you're finding lines, they will often talk about something like find a line that's parallel to, or find something that's perpendicular. Let's just remember, parallel means you've got the same slope or the same gradient, right? They're two lines that never meet. Okay, perpendicular is slightly different. Perpendicular lines means that they meet at 90 degrees. And so in other words, we're talking about the slopes. We're talking that their slopes will meet at 90 degrees. How do we find parallel and perpendicular lines? This is the best way to put it. If we have two lines, L1 and L2, and if they're parallel, that means they're gradients. So the gradient of line 1 is going to equal the same gradient as the second line. So that's nice and easy. If they are perpendicular, the rule kind of goes like this. The gradient of line 1 times the gradient of line 2 should give you -1. Okay, now I like to think of it as that one to the right is just a rearranging, but I always think, in my mind, I think negative reciprocal. Okay, the reason that it's a negative reciprocal is there's the negative, and reciprocal simply means that we flip one of the powers. I'll explain how that exactly works. Let's see how some questions may look. Okay, let's put it all together. Find the equation of a line. So again, I'm thinking after I see that line there, I'm thinking it's the point gradient formula. Okay, immediately, that's my first thought. And so it says here, I want to find the equation of a line that is parallel to that and goes through. So I know that let's start with this formula. Y minus y1 equals to m bracket x minus x1. That's my starting point. Okay, I'm always going to start with my formula and I'm going to substitute things in. Now, in this point gradient formula, I need a point. There's my point. So in other words, that 0 is my x1 and that 1 is my y1. Now, the only thing missing now is I've got my point. I'm just missing my gradient. Okay, now if it's parallel to this line here, in other words, does that make sense that that's my gradient there? My gradient of this line here is the m in front of the x. In this case, my gradient is 3. So from here, I can see that for me to be parallel, I need the exact same gradient, and I need to go through this particular point. So let's try it and see how we go. So I'm going to substitute in y minus y1. In this case, it's just y minus 1 equals to m. Now the gradient that I'm choosing is going to be 3 for this example because it's parallel to. Okay, and I'm going to go x minus, and x1 is going to be 0. Let's see what we end up with. Y minus 1 equals to 3 times x. And I'm just going to rearrange to get myself into this y equals to mx plus c form. Okay, so that there is going to end up being my answer. That is the equation of a line. It's parallel to y equals 3x plus 2, but it goes through the point 0, 1. Okay, that would be your answer there. Let's try the next one. Let's say I'm trying to find the equation of a line. It's perpendicular to this line here, and it goes through the point -1, -13. Okay, now again, equation of a line, let's start with y minus y1 equals to m bracket x minus x1. I've got a point. That is good. Now, the only thing I need now is a gradient. And I need to find the gradient of, I'll say perpendicular. So it's perpendicular to, and that's just the little symbol for perpendicular, 2x minus 2y plus 4 equals to 0. So I need to find the gradient first, which means I'm going to rearrange to put it into my gradient intercept form. So if you can see here, I've just pushed the 2y to the other side, and then I'm going to divide all the way through by 2. So this just becomes y equals to x plus 2, or let's write it this way. And from here, I can see that my gradient, if I'm talking about y equals mx plus c, can we see from here that my gradient is actually 1 from this line? Right, just 1. That's what it should be. M equals to 1. Now that's if it was parallel, but we know that m1 times m2 should be -1. So if one of my gradients is 1, now I just divide both sides by, I guess, 1, and it just gives me -1. Okay, I'll leave that down there. Hopefully that makes sense. If it doesn't, slow it down and I'll break down the steps for you. First, I found the gradient of the original line that they gave us. And to make it perpendicular, I just used the rule that said the two gradients multiplied together should give me -1. From there, I've let one of my unknown gradients be m1. And then the other one we found m equals to 1. And then we solve to find our gradient is m equals -1. Hopefully that makes sense. So now I've got everything that I need. I've got my y minus y1, and let's do this in blue. Y minus y1, which is y minus -13 equals to m, which was -1, x minus x1. Again, note how many brackets I'm using here. This is just so I don't make mistakes. Double negative makes a positive in this case, minus times -13. And then here, I'm going to keep my minus out here while I figure out this. That'll be x plus 1. Let's see what we got. Y plus 13 equals to minus x. It'll be -1. And then I'm going to minus 13 to both sides. And that should be my answer. Y equals to minus x minus 14. That's the equation of a line that's perpendicular to this line. And it goes through the point -1, -13. Okay. Whew, let's keep going. What if it goes through, let's find the equation of a line that goes through these 2 points, 2, -3, 4, -9. So if I want to find the gradient that goes through these 2 points, essentially, it's still going to start with y minus y1 equals to m x minus x1. Now, in terms of this, I need to pick a point. I'm going to let this one be my x1 and my y1, just simply because the numbers are smaller. So I've got a point. The only thing I'm missing now is a gradient. Now, if I've got 2 points, how do I find my gradient? Well, simply put, it's going to be our gradient formula here. So I'm going to label this as, x2 and y2. So let's now find my gradients. X2, the y2 minus 9 minus 3 all over x2, 4 minus x1, which is 2. That gives me -6 on 2, which gives me a gradient of -3. So now I've got a point. Now I've got a gradient. Let's plug it all in. Y minus y1, y minus -3 equals to m, which is -3. X take away x1, which is going to be x take away 2. And from here, let's just clean it up. Y plus 3 equals to -3x plus 6. Expanding the brackets and then just minusing 3 to both sides. Plus 3. That would be my equation of a line that goes through those 2 points. Okay. Hopefully it makes a bit of sense. Hopefully you can kind of see that we're just doing a lot of substitution, but I'm hoping that's making sense. I think that's it. I guess there's a sneak peek. We're going to look at problems next lesson. All right. I'll catch you guys later. Bye.